As you can see, our today's lesson is on lens. Okay, so today we shall read preliminary things about the lens. That's mean what is lens and all the technical terms related to lens. So first of all, let me talk about what is length. So actually lens is a transparent object generally made of glass, okay, and bounded by two spherical surface, either like this or like this, bounded by two spherical surface, sometimes one spherical surface, one plane surface, one spherical surface, one plane surface. Okay, so all these things are basically lens, and all of you already know. So this is known as the convex lens, this is known as the concave lens, this is known as the plano convex lens, and this is known as plano concave lens. So all these are lens. Okay, now just look at these things. One thing is very much common, that is this lens is a part of a sphere. This lens is part of a sphere. That's mean if two sphere intersects, then we get a lens, this type of lens. Similarly, this is also a part of a sphere, and these are also somehow they are the part of the spheres. Okay, this lens has another name, that is converging lens. This lens has another name, that is diverging lens. So that means when light ray passes through this lens, so after refraction they concentrate at a certain point. So that is why this is known as the converging lens. That means all the light rays are converging. Similarly, when light ray passes through this lens, they basically diverge from a certain point. That means there appears to diverge from this point. So that is why this lens is known as the diverging lens. Now the question is, why this lens is converging on all the lights, and why this lens is diverging all the lights? So let's talk about this. We shall explain the action of this lens by the action of prism. Okay, how? So let me draw an outline of the prism. Outline of the lens. So I am drawing the outline of this lens. So let's say this is the outline of the lens. Okay, now I am reconstructing it by drawing some prism. Is it okay? So these are the prism. We know this is a prism. So this is somehow like a prism. Okay, now let's say this is the axis. Now when a light ray fall on the prism, what happens? It always bends towards the base. So light ray bends towards the base. So these are the base. So light ray bends towards the base. Here this is the base, and the light ray bends towards the base. This is the base here. So that is why this lens act as a converging lens, because this is a prism and the light ray bends towards the base. Because we know if this is a prism, light ray pass through like this. That's mean light ray always bends towards the base. This is the base. This is happening here actually. But in case of this type of lens, again I am drawing an outline of that lens. So this is the outline of this lens. Okay, and I am reconstructing this lens by using some prism, this is a prism, this is a prism, this is a glass block, this is another prism, and this is another prism. So all these are prism. Now a light ray, I am drawing an axis here, let's say. Now this is a light ray, it will bend towards the base. Here this is the base, inverted prism is here, this is the base. It will bend towards the base. It will bend towards the base. It will bend towards the base. Is it okay? So that is why an concave lens shows the diverging action. Is it clear? Okay. Now we shall read about the technical terms related to lens. So technical terms, the first thing we have to know, that is what is center of curvature. Center of curvature, center of curvature, and we are denoted it by symbol C. Okay, let's say this is a sphere. This is a sphere, and here is another sphere. And as you can see, the intersection of these two spheres, that means this section is giving the lens, is giving us the lens, it is convex lens. Now center of this sphere, this C1 and C2, this C1 and C2 are known as the center of curvature. Center of curvature. Is it okay? So this is center of curvature. Now what is radius of curvature? So number 2, we shall read here radius of curvature, radius of curvature, and that is denoted by R. As you can see, this lens is part of two spheres, so the radius of this sphere is known as the radius of this sphere, that's mean this one and this one, this is known as the radius of curvature. Okay, so here basically two radius of curvature for a lens. So if R1 equal to R2, then we can say that this is a equiconvex lens. Means if R1 equal to R2, then this lens will be a equiconvex lens. Equiconvex lens. Means both sides are equally convex. This is similar for a concave lens too. That's mean, let's say I am considering another sphere here. Another sphere here I am considering. Okay, so this will give a concave lens. This is also center of curvature, and this is here the radius of curvature. Okay, and now if these two radius are equal, then that will be called the equiconcave lens. Is it okay? This is lens. Now let me tell you another thing. This axis, that's mean if you draw a axis by joining the two center of curvature of a equiconvex lens or of a convex lens, or in case of a concave lens also, if you just join the two lines, 2 points, okay, then you will get an axis. So this axis is known as the principal axis. What I am saying, the third term is here principal axis. So here the principal axis is C1, C2. Here the principal axis is C1 and C2. So C1, C2. Now I am doing one thing. I am drawing another lens. Let's say this is a lens, and I am drawing, this is the principal axis of the lens. Okay, now I am drawing a cross section here. I am drawing a cross section here. Okay, now do one thing. Let's say a ray of light is incident on it like this, and after refraction it is emerging from this side which is parallel to this ray. Now you join these two lines. Okay, and when where this ray is intersecting the principal axis, that point, that means this O point, is known as the optical center. What I am saying, this point is known as the optical center. This point is known as the optical center. I am drawing the same for a concave mirror too. Let's say this, concave lens too. A ray of light is incident on it and it is passing through here. Now this point will be known as the optical center. Keep one thing in mind, this ray and this ray are parallel. This ray or this ray should be parallel. These two rays will be parallel. Is it okay? So this is the optical center. The third term from here you have to know, that is focus. So what is focus? I am drawing another lens. Let's say this is the convex lens and this is the principal axis and this is the principal cross section, let's say. Now few rays of lights which are parallel to the principal axis incident on the lens. So what will happen? After refraction they will meet at some certain point. They will meet at a certain point. So this point will be known as the focus. So this point will be known as the focus. This is number 4 and this is number 5. Focus, or better to say principal focus. Principal focus. What will happen in case of a concave lens? So in case of a concave lens, let's say this is a concave lens and I am drawing the principal axis here. So some parallel rays are incident on it. Let's say this is the cross section, principal cross section. Now after refraction it will seem that they are coming out from a certain point. They are diverging out from a certain point. This point is known as the principal focus F. Okay, and this is the optical center O. This is the optical center O. So the distance between optical center and focus, that is known as the focal length. So another point we are getting from here, that is focal length. Okay, the next thing we shall read from here, that is focal plane. If you consider a plane which is perpendicular to the focus, this means this plane is known as the focal plane. If you consider a plane perpendicular to the focus, that will be known, on which the focus is situating, this plane will be known as the focal plane. Is it okay? This is focal plane. Next, what is secondary focus? If a principal focus is here, then there must be a secondary focus. I am drawing another picture here. Okay, so let's say this is a lens. Okay, and some rays are, and this is the principal cross section, incident on it, which are parallel to each other but not parallel to the principal axis. Then what will happen? Suppose when the parallel rays was coming, they will meet at that point. But as these rays are not parallel to the principal axis, so they will meet on another point. And which point is situating on the focal plane? That's mean which plane this point will situated on this focal plane. Is it okay? And this focus is known as the secondary focus. Number 8, secondary focus. Is it clear? Okay. Next, you have to read the difference between the convex and concave lens. So you have to read the difference between concave and convex lens. And keep one thing in mind, in case of mirror you have read this formula r equal to 2f, but in case of prism no such formula exists. In case of lens, sorry, not prism, in case of lens this type of formula is not valid. Is it okay? So keep this thing very carefully in your mind. Is it okay? So this is the basics of the lens, and we shall talk about lens in detail in next video. So you can check the link, you can check the description for the link of the next video. Is it okay? Okay, thank you. Subscribe my channel.